Hi guys, this is Tim McGuire again. Welcome to part 3 of my MITxPRO capstone presentation. I'm talking about my bad bank application, and in this section I'm going to talk about how it was deployed to the cloud from a local development machine, the new features I added to the application. I'll do an app demonstration, and then there's a reflection part at the end. During the development, as I mentioned in part one, I believe I had to learn the use of env files and Docker files. The env files, there's one that's common to the entire development process that has things like the app name in it, its version, its description, and then it's the ports that it's using. But I also learned that to make it easy to go from your local machine to a production cloud server, you should have env file extensions like development and production so that you can tell Docker and the deployment and the build pieces of that process what you're doing. I'm either on my local machine and I'm going to run on localhost, or I'm going to push this into a cloud with a real internet subdomain name like badbank.tjmco.io, and I want the application to run in that environment. And I don't want to change code while I do that. And the only way to make that happen is with env files and the .env utility. But Docker Compose then will read these files as well and bring in the things it needs so that when I'm looking at my development env file, I can see my domain and subdomain are just localhost. But when I go to the cloud and I'm in production mode, my domain is tjmcode.io, a domain I went and created and purchased. And then my app is going to be just a subdomain under that complete domain name. So whatever my app name is, in this case, badbank.tjm.io. I did my framework application app name, and it's up like that as a subdomain, appname.tjm.mcode. And then all of these things come together in the Docker file. So the Docker file can be common to every application we build. You don't have to reproduce these files over and over and over again. You have them reference an env file variable like app name, and the rest of the thing is common. You don't keep touching these files. You make them once, and they're the same files for every application you build. These are just some, this is my back end. Actually, this is my front end Docker file. This is my back end Docker file. You see they look almost identical. And here's my database. You see I'm just pulling in the Mongo image, but I'm building it inside my own Docker file so I can control the name of the constructor, in this case, something simple, but the app database port was the important part. All of this, I was exposed to GitHub Actions for the first time, all of this for the first time in the MIT course, but the GitHub Actions at the end, extremely powerful, allowing you to automate all these things, these tedious things you have to do all the time while you're developing. In this case, the transference of your work into GitHub with a history, and then the pushing to a production environment and out to the customer. All of that is automated by GitHub Actions, Docker Hub, and things like DigitalOcean. But making that all work where you don't have to do a lot of manual labor, the key to that is these env files. So again, I have three generic containers, and I have a generic action in GitHub that handles that generic framework I built with Docker Compose. So I have one action in GitHub that expects this Docker Compose file in the way I've been showing it for a front-end container, a back-end container, and a database container. All you have to do is change the app name with the environment variables and your port assignments, and then anything application specific, and then push it with a commit, and that one action takes care of it for every application I build at this point. This is a picture of that action in GitHub. You'll see it looks almost identical to my Docker Compose file, on purpose, of course. And understanding how closely those two things could be put together, it's just a beautiful thing. People have done some great work here that makes all of this work so well. Inside my actual application code, this is a peek into one of the database routines. You can see I'm creating a constant that builds my Mongo path. All of that is being built by referring back to these environment variables, so I never have to touch that code again. I can move the app from local machine to a cloud change the app name, change the database name, and I never have to go in and touch that code again. I decided to host it. Let's talk about the deployment now on the VM, the web side. I decided to host it in DigitalOcean, and I almost regret that, but I'll tell you why I did it. So I first started to do it with Amazon Web Services, and I found that to be extremely complicated, and there's so much help in Amazon Web Services that it's overwhelming. There's too much. You can go down a rat hole for an hour and lose yourself. So I took a quick look at DigitalOcean, and I was able to put my app up in DigitalOcean in a few minutes. So, and I'll talk about why that ended up being a mistake, but because I'm trying to build app name and bad bank and get grub, which I didn't finish, but the idea was to just make a production line. I wanted all of these apps running in one droplet in DigitalOcean. So I created my templates, my CI/CDs, my pipelines to get all this done. I went and purchased my domain names, some for the future, and then I went in and created a droplet, very easy. And then I got to the amazing feature that made this, like, it looks so good. They have something called Create App that can just point right to your Docker Hub. You give it the path to the images of the containers, and it understands that you might have an app that has multiple containers in it, and it lets you just add the containers into the app definition. This is how you pick it from Docker Hub, and then when you get it all built, it puts it all up there into I found out later it puts it up into another container that I didn't understand it was doing that. I thought it was putting them up in the host, the droplet you had created, but it's not. It's actually creating another container for them. But it allows you to point your subdomain URL to that app container that was created for you automatically. That made it seem so beautiful. As soon as I was done with this, I could go to that subdomain, and there was my application running. So that looked really good, and it's got all these nice features where you can rebuild from Docker Hub automatically. After that, just push a button and it goes and gets the containers again, and the application's up and running, and everything's working, the database works. And then I got to the problem. Not so fast. DigitalOcean might have been a mistake. What they do, because they launch your application inside of another container, even though my Docker Compose file says I'm using an external volume for my database, one that should be maintained and persist when the other containers are destroyed and rebuilt, every time I rebuilt my app containers, my database container was set back to nothing. It was destroyed. That's when I realized they were putting all my containers inside of another container and launching it as an application, which is cool, but they don't. I went back and forth with support with them. They don't have a mechanism to maintain that external volume for you, and they want to sell you database services. So at that point, I gave up their whole app product, kept the droplet, and learned how to deploy my own Nginx uh, server so that I could do reverse proxy serving of the subdomains and allow my app name, bad bank, and get grub to go to different port assignments in my droplet, so all three of those applications could run inside one virtual machine together without using any of these facilities from DigitalOcean. So as soon as I did that, I was able to get this same thing that was running on my local host machine, my development machine, that looks so nice in Docker Desktop, where my database was being maintained between app container reconstructions. I was able to finally get that working in my VM in DigitalOcean, but I had to do it all through Docker CLI, which took me back to the 1980s, but I did finally get it to work. And this is my back end running, or the droplet log files running. You can see the difference between the back end and the database and the front end things being logged. But that was an unexpected turn of events that burned days for me. Let's now move away from that kind of nightmarish deployment scenario. It is working, but that was not fun. And let me talk for a minute about the new features I added in. First, I started again with the app name template, and I added features into that template framework that I'm going to reuse forever, like the microcode server and microcode client classes or modules of functions. The two big ones that are in there are log and exception, where they take a message, a source, and a severity for logging, and in the case of an exception, message and source and the actual exception message, because an exception is always going to be classified as a fatal severity in my world. Using those are really simple. I just pull them out of my JavaScript client as log or exp, define a path that's used everywhere in the module for them, and then a single line of code, just like it's used just like console.log, and it relies on console to do all of this. But in my log statement, there's a message and then a source and then a severity. And that severity controls the colorization and the icons used in the log file and how I handle the other data. But it gives me events in the live log file that look like this, where I have an icon telling me what kind of event it is, and then it tells me it's coming from my M-code facility. It has the message colorized, a timestamp, where it came from, and then the severity in English as well at the end. This made it a joy to debug after I got this all done. This is what an exception looks like in the log file. It's in magenta. I can spot it immediately that I have an exception. And embedded in the logging synchronously is the stack dump by using console.trace in the right way and building my event log where you can, and it's collapsible, where you can open up a stack dump from inside that event right live in the event log and see what happened. That was invaluable to understanding this stuff, where I wanted to understand exactly what data is being passed back and forth from each layer to the next, and greatly helped. All of this stuff is up in my GitHub, and when I finally got done with those new features in the framework, the app name framework, I then replicated it into Bad Bank Capstone. And then I brought over all my work up to this point from the other Bad Bank iterations in the different frameworks, and I dispersed the code into front end, back end, and database. That wasn't as easy as I thought it was going to be, and I'm glad I had the logging stuff to understand because we had changed frameworks so many times during the course, we were exposed to so many things. I started to lose track of what the responses looked like from different things, like Axios wraps a response envelope around the data you want to get to, and it goes into dot data, and other ones put data into dot body. So there were some differences, and having the logging facility made it very easy to go out there and see what was happening. So all of this is up inside one project. These two projects are both public and out in GitHub. But once I had that framework done, this allowed me to focus on the app itself without worrying about Docker integration, my GitHub CI/CD path, Docker Hub storage, DigitalOcean storage, or JSDoc. All of that was defined in my app framework, so I could just code on Bad Bank and think about the actual application and not how it was being deployed. So that brings me to the new features. In the Bad Bank application from class, we had created create account, log in, deposit, withdraw, and view all data. I added the need for an initial deposit, just like a real bank, and an auto login when you make that create happen. So as soon as you create an account, you are immediately logged in. That exposed some assumptions I had made about what was happening in those layers. And again, having the detailed logging really helped me understand the assumptions that I had made incorrectly. Then I also added delete account right into the account card, log out into the login account, login card, view balance as a brand new feature, view transactions as a brand new feature, send money between users in the bank, and then I added in that card alert, user alert that I talked about, I think, in part one. And all of those card inputs are colorized just like the back-end events that are in the log files and in the console. And when those alerts are happening, they are being logged also in the exact same way into the event log. So what the user sees in the UI, I can see in the event log later.